In continuation to the previous video, we actually stop here, whereby the final answer to this is option B. Now let's move straight to the next question. Okay, I've solved this also, whereby I said this is option B also, and at the same time, we have question number 7 as okay. You want to find the limit as when x tends to 0 of x plus 1. The limit as when x tends to 0 of x plus 1 squared minus 1 over x. Now, if I go ahead and use direct substitution, if I substitute when x is equals to 0, then all this thing becomes undefined, right? Now, since it is undefined, you have to make use of what we call the L'Hospital's rule. And the L'Hospital's rule says that you have to differentiate, this is limit as when x tends to 0. You have to find the d dx of whatever you have, that is x squared minus 1, and at the same time, d dx of what? Of x. So that if this d dx cancel this d dx, it is still the same thing as what you have initially. So therefore, if I differentiate what I have up there, I have x plus 1 squared. If I differentiate it, that would be 2 times 1 times x plus 1 raised to the power of 2 minus 1, that's 1, minus 0. If I differentiate this x that I have down here, that's 1. So when I put in my the limit as when x tends to 0, we end up having 2 open brackets, 0 plus 1, right, over 1. And that's 2 times 1 over 1, that's 2. So let's check the option is not here. Let's check the next option. Option D is correct. Now let's move straight to the next question. Next question says, find the gradient of the tangent curve. Okay, the gradient of the tangent curve of, you have v equals to sine theta over cos theta plus sine theta. And then this is just um this is quotient rule, and the rule says that dv over d theta is actually equivalent to let's say vu prime. Okay, then let me use that definition to avoid confusion. I'm to take this down part, and that will be, if this is p and this is q, that will be q p prime minus p q prime all over what? Q squared. So what's my q? Q is cos theta plus sine theta, then times p prime is differentiate what you have up there, and that's what? Cos theta. Then minus my p is sine theta, and if I differentiate q now, that will be minus sine theta plus cos theta, then all over v squared, cos theta plus sine theta all squared. And in this case, if I open up this bracket, I have cos squared theta plus sine theta cos theta minus sine theta times this, that's plus sine squared theta, then minus sine theta times cos theta, that's minus sine theta cos theta. So this cancel this, I'll be left with cos theta plus sine theta, and that's 1. That's 1 over cos theta plus sine theta all raised to the power of what? 2. And here in this case now, okay, so therefore on substituting, we actually have, okay, on substituting, we have theta to be equals to pi over 3, right? And pi over 3 simply implies 180 over 3, and that's 60. So here in this case, let me try to work this off. So here in this case, now whatever we have to do now is, we already have 1 over cos 60 is 1 over 2, sine 60 is root 3 over 2. So you go ahead and square it. So that will be 1 over, if I square this 1 over 2, I have 1 over 4, plus, if I go ahead with the product, I have twice of square root of 3 over 4. You can try that on your own. Then plus root 3 over 2 times root 3 over, that's 3 over 4 in that case. So if I add this and this together, I will surely have 1. Then plus 2 cancel 4 here, I have root 3 over 2. And at the same time, if I find LCM in that case, 2 is the LCM, I have 2 plus root 3 left. So this is reciprocal, which is 2 over 2 plus square root of 3, which implies that option C is correct. So just try to simplify this yourself. You usually get option C. C is correct. And at the same time, the next thing for us to do is to move straight to the next question. So D is correct for this. The next question says, given x squared plus y squared equals to 5, find indication of the tangent. Just differentiate this thing implicitly. You have 2x then plus 2y dy dx. Differentiate 5, that's 0. So therefore, if this goes to the other side, you have dy dx. 2y dy dx equals to minus 2x. 2 cancel 2, then dy dx is equals to minus x over y. So therefore, this implies that my gradient is equals to minus x over y. At point, this is x and this is y. At x1, y1, you have x is minus 1, that's minus minus 1 over 2, and that is 1 over 2. Since the gradient is already equals to 1 over 2, the next thing for us to do now is to recall the formula for gradient, which says gradient is equals to y minus y1 over what? X minus x1. And then trivially, y minus y1 is equals to gradient times x minus x1 if you cross multiply in this case. And that will be y minus. My y1 is 2. My gradient is 1 over 2. And at the same time, I have x here, and my x1 in this case is minus 1. So therefore, we have, let me rub this off. We have to multiply through by 2. 2 times y, that's 2y. 2 times 2, that's 4. Then if I multiply this term here by 2, I have just x plus 1 left. So if I collect like terms, take this to that side, take this to that side, you have nothing left. I have x left here. When this 2y comes like this, I have minus 2y plus 1. When this comes like this, I have plus 4. Hence, the final answer is x minus 2y plus 5 equals to 0. Option A is correct. Next question is integrate 0 goes to 1. I have 2x plus 8x squared over 1 plus 4x dx. Now, trivially, I notice that if I differentiate what I have here, this is what will come out. So let me try to factor out. Let me factor out 2x. If 2x is common, I'll be left with 1 plus 8x squared divided by 2x. That is 4x. And I have 1 plus 4x left dx. So this will cancel this. Whatever I have left now is to just integrate 2x dx. If I integrate 2x, that's 2x squared over 2. Remember that I have to put the lower limit and the upper limit. Now that means 2 cancel 2, I have x squared of the lower and the upper limit. Substitute when x is 1, I have 1 squared, minus substitute when x is 0, I have 0 squared. So that's 1 minus 0. The result is what? 1. Option C is correct in that case. And as for this next question, which is question number 11, the first step we need to take in this case is that we need to find the rate of change of y coordinates. We need to find the rate of change of y coordinates with respect to what? To time. And then we have to make use of chain rule. That is, when I say find the rate of change of y coordinates with respect to time, that means I'm referring to dy dt. And dy dt, by the use of chain rule, I can actually use it as, since this is defined by y and x, so I can use the rule of chain rule as dy dx times, how can I have this dy dt back? It's by actually multiplying it by dx, so that this can cancel this, then I'll be left with what? Dt. So if this cancels this, I still have the same thing. Now the next thing for us to do now is to differentiate, is to find dy dx. We need to differentiate this guy here. Find dy dx. If I differentiate 4 root x, 4 root x implies 4x 1 over 2. And this one implies I have 2x raised to the power of minus 1 over 2. I believe you know how to do that. 2 over x half. And I have 2 times 1 over x half. And this 1 over x half becomes this expression that we actually have here. So therefore, the next thing for us to do now is to differentiate what we have in this case. Differentiate 4x raised to the power of 1 over 2. 1 over 2 times 4, we all believe that that will give us what? That will surely give us 2, right? Then the next thing for us to do is to go ahead and subtract 1 over 2 from subtract 1 from this 1 over 2. So therefore I have 2 in this case, then I'll be left with x raised to the power of 1 over 2 minus 1, that's minus 1 over 2, then plus, okay, minus 1 over 2 times 2, in this case I have minus 1, and I'll be left with x raised to the power of minus 1 over 2 minus 1, that's minus 3 over 2. This is just dy over dx, right? Then times dx dt. Dx dt is actually the increase at constant rate, okay, such a way that the x coordinate is increasing at a constant rate. This is like saying you have the rate of change of x coordinate with respect to time. It is given as 0.12. Do you understand that now? So you are multiplying it by what? 0.2. Dx dt, the rate of change of x with respect to that rate of time, is 0.12 in that case. So therefore, here in this case I have 2 over root x minus 1 over x is power of 3 over 2, and x is power of 3 over 2 is x root x, right? So if I find the LCM in this case now, the LCM is x root x. If this cancel this, I have 2x left. Then minus, if this cancel this, I have 1 times 0.12. Recall that you have to find the rate of change of y coordinates when x is 4, and this is the rate in this case of y coordinates. And then at when x equals to 4, you have 2 times 4, that's 8. 8 minus 1, that's 7 over 4 root 4. And that's 4 times 2, that's 8 times 0.12. If you use calculator to do this now, if you do 7 over 8 times 0.12, the result will be 0.105. Please take note of this explanation. Option B is correct for this question. Option B is correct. Now let's move straight to the next question. B is correct here. The next question here says, find the point of discontinuity of p of x is equal to 3x over root x minus 4. The point of discontinuity is actually when the denominator is equals to what? 0. When it is undefined. When this down part is undefined, that means when this is equals to 0. Then you have root x is equals to 4. When you square both sides, you know what to do. Then x is equals to 4 squared, and that is what? 16. Option B is correct. Next question. That is question number. What is the domain of this function? The domain of this function is actually, okay, you have to find the undefined function first, which is, okay, x squared minus 3x. Equate it to 0 and then find the result. That is, you have x of x minus 3 is equals to 0, right? And then I have x is equals to 0 or x is equals to 3. X equals to 0, x equals to 3 simply implies that you have this thing to be undefined. Now, what will now be the domain? Domain is just as if you are expected to write this 0 you got here and this 3, which implies you are not including 0 and you are not including 3. So as far as it is not close, if I use this bracket now, that means 0 is included, 1 is included, 2 is included, 3 is also included. That is 0, it is close at 3 and it's also close at 0. But if I write it like this, 0, 3, it implies, if I put square bracket here, this implies that 0 is not included. That means I have 1. For this expression, I have 1, I have 2, I have 3 is also included. But if I now have 0, 3, it implies that I have just 1, 2. And 1, 2 is a solution of this. If you put 1, 2, you usually get a solution. That's the domain. And then what else can you also have? Union. I can also have, that means I must not have 0, I must not have 3. That's just the condition. Then that means I can have starting from 4. So that means I can actually pick, it is not closed at 3. That means I have 4, 5, 6, 7, 8, 9, 10, up towards infinity. And at the same time, I have another union. So what else can I pick? Since I've already picked 0 here, then there's another thing I can actually do in this case. What if I use 0? Yes. Then I will surely have minus 1, minus 2, then minus 3, up towards infinity. So that means option D is very similar to what I need. X is a member of negative infinity is there, please. Minus infinity 0, union 0, 3, union 3, comma infinity. So option D is correct for this. Please take note, this is the domain. This is the domain of